Hello everyone, welcome to Robert Morris University, Chapter 1, Lesson 7. This is Brianne Pernick. In this lesson, we are going to work on identifying like terms and combining like terms. Now, throughout the sections that we have worked on so far, you have heard me talk about these vocabulary words and even explain them a little bit. The reason that we have had to talk about them and explain them a little bit so far is because they are used so frequently throughout pre-algebra as well as algebra, and they are a prerequisite knowledge that you have needed up until this point, but they weren't introduced yet in our curriculum. A little bit backwards, right? Now, before we actually discuss what a like term is, I do want to review with you what a term is, because I do feel like that is useful for us to know. Now, terms are the individual pieces of an expression that are separated by plus and minus signs. When we put our terms together to make a mathematical expression, we read each term using addition and subtraction. For example, if we look at this expression, we would say 2x cubed plus 5x squared minus 6x plus 9. However, if we separate each one of those terms out according to their plus and minus signs, we will see that there are how many actual terms in this expression? What do you think? Well, keep in mind that I said that we're going to separate them according to their plus and minus signs. So the first term is a positive term because there's nothing in front of it. The second term is also positive because there's a plus sign directly in front of it. The second term is the negative 6x, and the last term is the positive 9. So you can see that there were 4 terms in that expression, and they were separated by their plus and minus signs. Now that we know what a term is, let's start talking about like terms. Like terms need to be thought of as like quantities, because, and I should say, and because they're like, we can combine them together to simplify our expression. Okay? Plain old numbers, such as the term of 9 that we had in our previous example, should always be considered like terms, and you should always combine them together using addition and subtraction as noted by the sign in front of that term. Okay, now I say right here in this note that like terms need to be thought of as like quantities for a reason. When you have a 2x, a 3x, a 7x, think of that as something concrete rather than an abstract x. Think of it like having 2 apples, 3 apples, and 7 apples. How many apples do we have altogether? 2 plus 3 is 5, plus 7 is 12. We have 12 apples. If you think of them as quantities rather than terms, it makes that abstract concept a little bit more concrete for you, and perhaps a little bit more easy to understand. Similarly, if you think about having your x's, which were our apples, and y's maybe as mugs, like coffee mugs, then you can think about how different those two items are. I'm not going to pick up all of my apples and then pick up my mugs and put them in the same basket. That wouldn't make sense to do that. So that is what the concept of like terms is doing. You are picking up all of your items that are the same and combining them together so that your expression can be more simplified and nicer to look at. That's what's happening there. Okay? Now, in order for terms to be considered like terms, when the variables are involved, every single thing about the variable portion of that term has to be identical. So it has to have the same variable or variables, and it has to have exactly the same exponent or exponents if that variable has more, or if that term, has more than one variable component to it. Okay, so let's look at some examples here. Let's simply list the like terms in the following expressions. I'd like you guys to take a stab at this first. So go ahead through A, B, and C. Go ahead and list which terms you think are the like terms in those expressions. So pause the recording, list them, and then we'll come back together here when you're done and check it. Okay, at this point, you should have paused the recording and listed the like terms in A, B, and C. So let's see how you did here. In letter A, the terms that were like terms were 5x and 6x. There were no other terms in that example that were like terms. In letter B, the only terms that were like terms were 4a and negative 9a. Please remember that the sign that is in front of the term belongs to the term, and you have to bring it down with it everywhere that it goes because it's part of it. Okay? And in letter C, we do have two sets of like terms. The first set is 7m squared and negative 3m squared, because those ones have an m and a squared with them. Remember, everything about the variable as well as the exponent must be identical. And then the second set is the positive 10m and the negative m. Hopefully you guys did okay on that. All right. If you have questions, please make sure that you let me know, because this is an extremely important concept in algebra, and we need to make sure that you guys can combine like terms. Now at this point, we are going to move on and start actually combining these like terms. And at this point, we are going to revert back to our example about the apples. Okay. Now, I did leave out my little coefficient here for this. I had 5 apples written here. Sorry about that. Now, add that to your notes. If you have 4 apples plus 9 apples, how many apples do you have? We know from probably first grade that 4 apples plus 5 apples in our basket is going to make 9 apples. That's simple addition, okay? Combining like terms works in exactly the same way that combining the apples did. Okay, you need to remember that like terms are nothing more than like quantities, similar to those apples, similar to those coffee mugs. Maybe you like oranges, bananas, something, okay, whatever you want to think of them as. It would be like putting all of the X's or all of the Y's into one fruit bowl and combining them up and making your expression more simple. So 4x plus 5x makes 9x. That's all we're doing there, is combining our x's. Nothing changes about that variable. We're just simply combining them and putting them together. So let's look at some examples here and practice this. For letter A, we have negative 4x squared plus x squared, or 8x squared, excuse me. They are like terms, we just want to combine them, so we're going to use the rules of addition. Negative 4 plus 8 makes 4x squared. We're just combining them. We're putting all of our apples into a bowl. If you have 8 and you take away 4, you're left with 4. Letter B, 13n to the fourth minus 8n to the fourth. 13 minus 8 gives us 5n to the fourths. Letter C, why don't you guys go ahead and try this one on your own. Pause the recording. When you're ready, press play again and we'll go ahead and check letter C together. Okay, for letter C, you should have started by saying that 7 plus 6 makes 13y's. 13y's, take away 3y's, is going to leave us with 10y's. Now, if you did all of that math in one step, that's perfectly fine. Okay, perfectly fine if you did all that math in one step. Letter D. Letter D. Go ahead, try that one on your own. Pause the recording and then we'll go over the answer. Okay, by now you should have completed letter D, and we will see here that we have negative 3a cubed plus 6a cubed is going to give us 3a cubed minus a cubed. So 3 minus 1 gives us 2a cubed. Again, if you did all of that math in one step because you're doing that math either on your calculator or in your head, that would be okay as well. Now, letter E, you're going to notice that you have 3 different sets of terms. So you need to identify which ones are like terms and which ones are not. Please go ahead and try letter E. When you are ready, we will go over the answer together. Okay, at this point you should have solved letter E, and when you did such, you should have seen that you only have one term that contains an S. Since you only had one term that contains an S, it cannot be simplified with anything else, so we're simply going to bring it down. Now moving on to the T's, we have negative 4t plus 2t. Those are like terms, so they can be combined. Negative 4 plus 2 does make negative 2t. Lastly, we have a constant. It is the only constant in our equation, so since we have no other constants to combine it with, we are simply going to bring it down. Please keep in mind that in an algebraic expression, your variables should always be written in alphabetical order. Letter F. Letter F. Go ahead and give that one a shot. Pause the recording. When you're ready, we'll be here to go over the answer. Okay, by now you should have completed letter F, and we are ready to go ahead and go over the answer together. Like terms mean that every single thing about the variable and the exponents match. So as you are scanning your expression for like terms, the first term you come to is a c squared d. That means that in order to find another like term, you need to look for a c squared d. And we do find one right there in the negative 7c squared d. Every single thing about those variables and exponents must match. They must be mirror images of each other. So we can go ahead and combine those. We have 2 minus 7, which makes negative 5. C squared D. I like to cross out my terms once I have used them so that I know I have taken care of them and that I've brought them down, and it helps to see what's remaining. So the next term we have is a CD squared, and then we have another CD squared. So we can go ahead and add those together. 5 plus 1 makes 6 CD squared. At this point, we have simplified our expression. There's nothing further that we can do, and we are now ready for letter G. Go ahead and pause the recording. As soon as you're ready, we can come back together and check your answer. Okay, as you are looking at letter G, you will notice that as you look for another x squared y, there are none. So we can simply bring 6x squared y down into our next line. Next, you are going to look for a 9x, just an xy. There are none. So we're going to bring that one down. Then we're going to look for an x squared y squared. There are none. So we're going to bring that term down. That leaves us with just the same exact expression that we started with. Sometimes this happens. It cannot be simplified because there were no like terms. In a situation like this, it would have been okay to simply write cannot be simplified. Letter H. Go ahead and solve letter H for me. Whenever you are ready, please unpause the recording and we'll go over the answer together. Okay, at this point you should have solved letter H. Let's start to go through this one, and we're going to look at the problem. The first thing that you do in a situation like this is start with the letter that comes first in the alphabet. So we are going to start with the letter C. We have -8C and 2C. So -8 plus 2 makes -6C. I'm going to cross out my C so I know that I've used them. Then I'm going to move on at this point to my D's. I'll explain why in a moment. We have 3D plus 5D, which makes 8D. Cross those out. And lastly, I have D squareds. So I have 1D squared minus 3D squared, which makes -2D squared. Now you may have remembered earlier in the lesson that I said that your variables should always be in, your exponents should always be in descending order, meaning that we start with the biggest power and go down. Well, that's not what I've done here, right? My exponents go 1, 1, 2. Why did I do that? Well, the reason being is because we have two different variables, and we always start with the variable that comes first according to the alphabet. So that variable would be the one that goes in descending order. After that, our second variable would go in ascending order. So the D would have to go in order from smallest exponent to biggest. Moving on to letter I. This one is a fractional example. Please go ahead and pause the recording. Take a minute to solve it, and then we'll come back together. Okay, for this particular example, the first thing that we want to do is combine our C's. But before we can combine our C's, we do need to get a common denominator. So for these fractions, since we have a denominator of 3 and 2, I would change them to a denominator of a 6. So for the first fraction, in order to get to a 6, we would multiply 3 by 2. So we're going to multiply the 2 by 2. So 2 times 2 makes 4. So we have negative 4c plus, then we want to change the 1/2 to a denominator of 6. So 2 times 3 made 6. 1 times 3 will make 3 C's. Now, I'm going to leave those the same for just a moment, and let's work on our D's. In order to combine 2D minus 4/5, we will have to get a common denominator. So this at this point is a 2 over 1, and we will have to change them to a denominator of 5. So in order to turn a 1 into a 5, we will multiply by 5. So 2 times 5 makes 10D minus, because the 4/5 is a minus. This one does not have to change at all. We're just going to leave it 4/5. So now at this point we do have fractions that have common denominators for our like terms, and we are able to combine them. So we're just simply going to add and subtract as we normally would. So we have negative 4 plus 3, which leaves us with a negative 1/6 C. And for my D's, I have 10 minus 4, which gives me a 6/5 D. Now, usually I tell you never leave a fraction as an improper fraction and always simplify it. But in a case like this where you have multiple variables and they are in an expression string like this, please leave them as improper, because you never know, at some point you are going to have to multiply, maybe divide with that type of fraction, and you cannot multiply a fraction if it's in the form of a mixed number. So save yourself a step, leave it improper so that you can work with it in your future. Okay, last example requires you to distribute, combine like terms, and simplify. Go ahead and pause the recording, solve this last example, and then we'll come back together. Okay, at this point you should have solved letter J and you should be ready to go over the answer with me. So for letter J, you will notice that in our first quantity we have 2y and 3. We cannot combine anything within those parentheses, so we must distribute. So we are going to take our 7a and multiply it to both the 2y and the negative 3. So 7a times 2y makes 14ay, and 7a times negative 3 makes negative 21a. Now on the second part of this problem, we have a 5ay and a negative 4a inside the parentheses. Again, those cannot be combined, so we are going to be distributing a negative 3 into that quantity. So we have negative 3 times 5ay, which makes negative 15ay. And we have negative 3 times negative 4a, which makes a positive 12a. Please watch your signs through the distributing and your multiplication. It is very important that you have your accuracy of your signs, or else your problem will not be correct. At this point, you are ready to combine your like terms. So we're going to start with our AY's. We have 14AY and negative 15AY. 14 minus 15 will give us a negative 1AY, so we're just going to write negative AY. The 1 is not necessary and it's not appropriate to put it there. And then lastly, we have negative 21A plus 12a. Negative 21 plus 12 is negative 9a, and there is our final answer. If you guys have any questions about anything that we went over in this lesson, please contact me and let me know. I will be more than happy to help you out. Thank you.